question, alien dictionary. So for this question, I'm going to use an algorithm called topological sort. And topological sort normally goes with BFS. And topological sort is done on directed acyclic graphs, known as DAG. It means the graph needs to be directed, and also it needs to be acyclic, meaning it doesn't have any cycles. And let's start. So first I'm gonna import some tools that I'll need for my data structure. From collections, import default dictionary and a counter. So for default dictionary, I'm gonna use it for topological sort. Normally comes with like two lists, not lists, but data structures called indegree, where it stores all the all the arrows pointing to the node, and outdegree, meaning storing all the arrows going out of that current node. So for the outdegree, I'm gonna use a default dictionary of a set to store all those things, and for the indegree, I'm gonna use a counter in this case. And let's start writing our code. So let's define some things first. So for indegree, it's gonna be a counter, and it's gonna be initialized with all the characters pointing to 0 in the very beginning. So for this question, we want to figure out this alien language's alphabetical order. It's different from our usual alphabetical order. It's like random. They give you all these like words, and we have to figure out this alien language order. So at the beginning, all of the indegree, we're gonna initialize it at 0, and we want to point each unique character to 0. So for C in words, let's do C point to 0 for word and words for C and word. So this point divides this list of words down to each one, and then for each unique character, since we're using counter, we're gonna initialize it at 0. And then for our outdegree, I'm gonna use an adjacency list with the help of a default dictionary of sets. So it's gonna be all unique. We can start populating our adjacency list in indegree. To do that, I'll do for word 1, word 2, in sub of what's given to us, words, and words 1. It means we'll compare the first word to the second word each time. So basically this words list is everything here. Then the words 1, we're using slicing, will be everything here. So each time we're going to compare this to this, then this to this, and then so on. So after breaking the word down one by one, we're going to break it down furthermore by looking at character 1 and character 2 in each word. So for character 1, character 2, and sub of word 1, word 2, now we're finally going to compare if these characters equal each other or don't equal each other. So if C1 does not equal C2, then we want to see if it's already in our adjacency list. So we want to check if C2 is in adjacency list of C1. Is not in. If C2 is not in adjacency list of C1, then we want to add C2 to C1. So adjacency list C1 dot add C2. We don't use append since our default dictionary is a set, so we use add. And then notice that when we add this adjacency list, we're saying C1 points to C2 right now, and C1 is like at level 0, and C2 is like the next level. It's like C1 is a prerequisite of C2. That means we need to increase C2's indegree by 1. So indegree of C2 should increase by 1 it just means in the order, like we have to get to C1 first before we can get to C2. It means like C1 character comes before C2. We just break. And then otherwise, we have something called a for else clause in Python. I don't think it's very popular. It's called for else. So AUSE clause. It just means if we never reach this break, if break is never reached, it means C1 has been equal to C2 up until now. C1 has been equal to C2 up till now, and this is like the else of what we do. If it's equal to C2 up till now, then we want to check for something to see if word 1 is greater than word 2, then that means this is an invalid entry. So we want to do something like if length of word 1 is greater than. Before I write it, I just want to show you guys here. It says if where they differ. A string S is alphabetically smaller than string T if at the first letter where they differ, the letter in S comes before the letter in T in the alien language, and if the first min S length, T length letters are the same, then S is smaller if and only if S length is smaller than T length. So word 1 has to be smaller than word 2 or else it wouldn't work. So if, let's say in this case, they've been equal up till now, if length of word 1 is greater than length of word 2, we can just return an invalid, no solution here, and go on to the next comparison. And right now we have populated our indegree and outdegree, and we can start our queue for the BFS. So for our queue, we initialize our queue with all the nodes in our indegree that has 0 dependencies. So we want to check for, let's do C for C in degree if in degree of C equals to 0. So we start with, we enqueue everything in our, like all the characters in our list in degree where they have no dependencies. And before we start writing our BFS, we can have an output list to store our output word. And I think we can start now. So while queue, we can pop our first character from our queue. We can do character equals queue dot pop 0, and then let's add this character to our output. So output.append character. And then we can go through this character's neighbors. So for neighbor in adjacency list of this character, if, actually before we do the if, we want to check, we want to decrease the indegree of the neighbor, because right now we've already visited our character, our character that we popped here. That means the first level is already visited and our neighbor no longer has that dependency on the first level, so we can decrease the indegree of our neighbor by 1. And then we want to check if currently there's any neighbor that has 0 dependencies, and if there is, we add it to our queue. So if indegree of neighbor equals to 0 right now, we can do queue dot append neighbor. I think this is it for the BFS, and at the end we want to check if we have sorted all of these unique characters in our list by comparing it to, by comparing if the length of output is smaller than, if the length of output is smaller than the length of the indegree, that means we haven't gotten everything in every unique character in our indegree in the output. Then that means it's an invalid invalid output, we just return nothing, an empty string. And then otherwise, we can return our output but joined together as a string format because currently our output is a list. If C2 not in adjacency list C1. Oh, I put the break in the run level, so if C2 not in the adjacency list C1, and then we do this, but if it's already in our adjacency list, we just break and go forward with the next characters. Yeah, so this is the solution for alien dictionary using a topological sort plus BFS. Please let me know if you have any questions in the comments, and thank you so much for watching.